Okay, so let's switch gears and talk about geometric sequences. We spent some time talking about arithmetic sequences. Now with an arithmetic sequence we have what's called a common difference, right? So the difference between consecutive terms is constant. It's linear in nature. When you look at the rule, you have an input-output relationship that models a constant rate of change. That's why we use a lot of the linear properties for that. Geometric sequence is any sequence of numbers that have a common ratio, right? And what does the word ratio mean? Ratio is just a fancy word for a fraction, right? So instead of subtracting, right, common difference would be subtraction. Common ratio means that the ratio of consecutive terms remains the same. If I divide A2 by A1, I should get the same thing as if I divide A3 by A2. So we divide like this in that direction to get the number that we use to go in the other direction, right? So just as a quick little aside, if I have just a very simple arithmetic sequence, what are these numbers going up by? They're going up by 2, right? But to get that number, I do 5 minus 3. Or I do 7 minus 5, or I do 9 minus 7. So I subtract going this way so that I can find the number that I use going that way, because each one of these is 2, right? So that's the common difference in an arithmetic sequence. For a geometric sequence, okay, we divide this number by this number, and what we get from that, we call that the common ratio, and we call that R, okay? So this common ratio is notated by R, but to use R, I multiply going forward. So when you look at that sequence, the first term times the common ratio will give me the second term, okay? Now there's this other thing that we're going to see a lot and it's going to be very useful in geometric sequences, and that is if I wanted to jump terms, so to speak, right? A squared, the second term in the sequence is the first term times the common ratio, right? So see if you can follow this for a second. So that would mean that the third term would be the second term times the common ratio. But if I substitute this in place of this, because they're equal, if I put this here, I could say that the first term times the common ratio times this common ratio, that's also equal to the third term, right? So that would be the first term times the common ratio squared equals the third term, right? I could keep going and going and going with this if I wanted to. I'm not going to do that, but you see how if I have any term number, I'm essentially taking the common ratio to some exponent to get to any term that I want, right? And you'll find this out the more we go along, that if you take these two numbers and you look at this number, what do you get, right? The sum of the term number, not the term value, right? But the term number, its address in the sequence. If we take that number and we take a power of R and we add those two numbers, we can get any term that we want. So if I had, let's say, if I knew the seventh term in a geometric sequence and I multiplied times the common ratio 3 times, where would that put me in the sequence? So if I had the seventh term, okay, and I multiply by the common ratio once, twice, 3 times, I'd go from the 7th term, 8th term, 9th term, all the way up to the 10th term. And that is pretty powerful information going forward. Now, the general rule for geometric sequences, sorry, I may have got ahead of myself a little bit, but the general rule for geometric sequences looks like this. So this is akin to this rule for arithmetic sequences, right? If I want to know any term, I can put in the term number, multiply it times the common difference, and add that 0th term, right? This is the explicit, the general explicit rule for arithmetic sequences. This is the general explicit rule for geometric sequences. So if I wanted to know the 8th term in a geometric sequence, I could take the first term and multiply it times the common ratio to the, what would that be? That'd be the 7th power. And that's kind of what we just talked about. We talked, this is a to the first times the common ratio to the 7th power. But that's not the only way I can get the 8th term, right? So just as an example, the 5th term, right? Well, if we use this formula, that would be the first term times the common ratio to the 4th power. And like I said, like I showed you on this slide, sorry, where'd it go? There it is. Like I showed you on this slide, as long as these two numbers add to be that, we're going to be able to find any term that we want. So coming back here, that could also be found by taking the second term and multiplying by the common ratio how many times, right? We want this and this to add to be that. So that would be the 3rd power of r. Okay, this idea is way more useful than this idea in a lot of the instances that we look at, a lot of the problems that we are trying to solve. Okay, so last but not least, if I had this problem here and I said, okay, I want to know the 11th term, but I only know what the 8th term is, okay, and I know the common ratio, what number goes up here? 3, because 8 plus 3 is 11. So find, this is any term I want to find from any term in the sequence can be found by taking some power of the common ratio. Okay, very useful stuff for geometric sequences going forward.